Great, thank you. Hi, everybody. Happy Friday. So I'm Brad Surak. I never thought I'd work for GE, to be honest with you. I've been here for 2 years now. I've spent most of my life, the last 20 years, working for enterprise software companies here in the Valley. And GE wasn't really on my radar screen until a couple years ago when they started to make big investments into the industrial internet. And so that's what I wanted to talk to you about this afternoon, was give you some insight into some of the things that are going on in other software markets other than enterprise and the consumer market, but some pretty interesting stuff is happening in old industries that are 100 years old, like locomotives and aircraft and the power generation and all that kind of stuff, healthcare, and show you what we're doing at GE, because it's a pretty cool stuff. First thing I want to talk about are some of the trends that are going on in the industrial businesses. And the industrial businesses are kind of slow adopters of information technology, but they've woken up to the fact that analytics is critical to their businesses. You know, it used to be you'd make a lot of money selling an aircraft engine or a locomotive or something like that, but nowadays you don't make very much money doing that sort of thing, and most of the money that we make is from monitoring the data and performing services on those pieces of equipment. We used to get very little data off of the equipment. So when it came to an aircraft engine, for example, we'd get some diagnostic data off of the engine on takeoff. We'd take some at cruise. We'd get some at landing. It would all be averaged. It'd be very small data sets, whatever you could store on the plane in flight, and it would be downloaded, physically only occasionally. So we'd use it for very limited purposes. Nowadays, there's about 120 sensors on the average aircraft engine, and we get about 1 million pieces of data off of every flight. There's a flight, the average engine flies about 4 times a day, so there's a GE engine taking off roughly every 2 seconds in the world. And we download that data. We're not quite in real time yet while it's in flight, but anytime we're in range of a Wi-Fi connection, so that go in-flight service that you get, or whenever we're landing at an airport, the engine data is downloaded and sent back to a central control center and analyzed, so that we can monitor the performance of that engine, and we can direct certain things about the engine that will improve how it's operated in flight or how it's maintained. The second piece is the ability to connect these machines to the internet. All the machines that are in the industrial space used to be complete silos. They used to be completely disconnected. They may be connected to some monitoring or some control software that was running on a small Windows box close to the machine, but nothing was connected to the internet. Now we're finding most of the machines are becoming connected, and it's our mission at GE is to connect everything that works within a plant or within a hospital or within a railroad, all of that stuff to the internet, including your hot water heater. You can buy a GE hot water heater that connects to the internet. But if you think about what happened when 1 billion people became connected to the internet, and most of you are developing applications in this space today, and using all the data that those users generate, just imagine what can happen when 50 billion machines are connected to the internet. And what we're seeing is a lot of this technology that was all siloed before. Like I said, these old SCADA systems that would monitor the machines, maybe tweak some controls on the machines, open a valve or close a valve. These systems are now, we call that operations technology. That's that OT. That technology is a very niche set of software. Small companies develop that software. It's not accessible to the average developer to go out and access data from these machines and understand these control systems. Now a lot of that technology is being virtualized, and a lot of what we're doing today is leveraging the open source software that's used in the consumer internet and in the enterprise space, and we're bringing it into an open platform or an open standards-based platform that allows developers to build applications on top of this machine data. And we're seeing this integration of information technology and operations technology so that the software becomes integrated with how the machine operates. The analytics that we can do on this data then help us predict how the machine is going to operate and help us maintain that machine and help us find ways to get out ahead. It used to be a lot of times, give you an example, there's these pumps that go down into the, 10,000 feet down at the bottom of the ocean to pump out some of the hydrocarbons out of wells and things like that. These pumps didn't have any sensors on them, didn't have any way to know whether the pump was working or not until the oil stopped flowing. Nowadays, we're able to monitor those pumps. We're able to predict what kind of maintenance they need so that when they're pulled out of the ground, we know exactly which parts to change. We don't just change everything, which is what they used to do in the past. And we're able to create backup systems on these devices so they can detect when they're having problems, and then they can self-heal and self-correct over time with their operation. And we're pushing this information out to people in the field. So mobile for us isn't just iPads and iPhones, although our guys use a lot of those. It's ruggedized devices, people that are out in hot and harsh conditions. Most of the people that work for companies like GE or Siemens or these companies, they work in oil fields. They'll work up on top of transmission towers, or they'll work in, working on wind turbines, things like this, in really challenging environments. And so, and with very limited connectivity. So we have to get very creative with the network. All the different systems that we need to develop the software is challenging for us. The changing architectures that we've seen in the consumer space and in the enterprise space is finally making its way over to the industrial side as well. And we're adopting the consumer grade architectures now, really leapfrogging the client server stage, because a lot of the systems were these dedicated systems for these equipment. So we're going right to the consumer grade architectures. We're making investments in companies like Pivotal Systems, Green Plum Technologies, and the app fabrics to build web-based applications for the industrial equipment. That means for us now, it's all the same sorts of challenges that you have on the social data or on some of the point of sales data, but the data sizes that we're seeing are so big, and we're needed to build analytic applications that can be used by our technicians in the field, oftentimes in real time or near real time sorts of environments. So, and we have to figure out what gets embedded in the machine so that the machine can actually run these analytics locally and then impact a control system. So we can do things like monitor how a gas turbine that generates electricity is performing. We can see what electricity prices are doing. We can help an electric utility operator say, hey, we're going to make a lot more money if we run this piece of equipment above its design tolerance, and it's going to make the maintenance a lot more expensive. And we can do that calculation in real time, and we can help that machine kind of over-rev itself, over-fire itself, and it's going to, in the end, generate more money for the utility or make the power grid more stable. It's going to change the maintenance of that machine or the maintenance needs of that machine. All of that sort of thing happens in real time. This real-time analytics is the key for us. So we're hiring we have about 1,000 people down in San Ramon now. We built this center over the last 2 years. It's about $1 billion investment for GE. A lot of data scientists, a lot of application engineers, and user experience for us is also critical. And this real-time analytics is built into everything. So a lot of what we're doing is working with the GE businesses to design real-time analytics into the equipment. So let me talk a little bit about how these systems work. The machines that we have, they're everything from aircraft engines, MRI machines. They're locomotives. We have 14,000 locomotives in North America that get monitored in real time, and we can pull data off of those locomotives, direct them into a maintenance bay whenever they need any kind of work, and direct what kind of work needs to get done. So that data is pulled off of these machines. It goes into a local data store on the machine, and then the machine itself uses that to optimize how it's running. Then it gets sent into the cloud, and we run predictive analytics on top of that to try to determine how that machine is performing and to use it both for maintenance data and to help it improve its performance. So we can take that data off this locomotive, we can analyze what work needs to be done on it, or we can feed throttle settings back to the locomotive by knowing how much weight that train is hauling, how fast it's going, where it is in the world. If it's climbing a hill, we can feed back a throttle setting to the operator to tell the operator that to set a throttle setting, it can get up the hill and coast down and save some fuel on the journey. We can then, when the locomotive comes into a maintenance shop, all the history of the operation of that locomotive and all its parts are then put into a mobile device so that the person who's working on the locomotive knows exactly what parts need to be changed. If that person has a challenge in fixing the locomotive, they can push a button and do collaboration, real-time collaboration with an expert anywhere in the world who can kind of guide them through the process of repairing a piece of that locomotive. And so this integration between the machines, the traditional sort of cloud-based applications, and then the physical networks like the rail systems and the human networks are the kind of problems that we're challenged with today. To give you an idea of the size of the data, one gas turbine compressor blade, so just one of those blades in this gas turbine can produce 500 gigabytes of data per day. And we have these very sensitive sensors on these pieces of equipment, and we can get just massive amounts of data. So the kind of data sets, and all this data was just going and wasn't even being collected. It was available, but wasn't being used up till a few years ago. But now what we're doing is building a platform that can take this data off of those sensors at volume and velocity and can perform different levels of analytics and simulation on it so that we can do a lot of the different use cases that I was discussing. The real purpose of all this, though, is to drive outcomes that matter, and that's one of the cool things about working for a company like GE. You know, they produce a lot of equipment that can really impact people's lives, and I think that's, for me, coming from just general enterprise software companies into a company that produces medical equipment and a lot of this equipment for the electric power grid, it's been a really interesting experience. You get to work on some projects like we were able to take a risk algorithm that was originally developed for financial risk calculations and put it into an ultrasound machine, and then use that to help a technician diagnose the risk for a cardiovascular disease. And so it's putting these analytics into devices that have a real impact on society and on the way that we all live. We talk about the power of one because we feel like if these analytics, and we can use these analytics to do optimizations that can produce 1% improvements in certain areas of operating these equipments, this is some of the results that we can get. So we can, 1% improvement in the rail industry can increase the velocity of the traffic on the nation's railways and produce a $27 billion revenue for the industry. Same thing on the healthcare side. $63 billion of value can be created through optimizing processes. And these are processes that they're not just generating money for the hospitals or for the insurance companies. They're things like we have a system that can help schedule hospital beds when you come into the emergency room. Some patients were waiting 7 hours to get into a hospital bed. So predictive analytics can predict the flow into that emergency room and can schedule hospital beds. I'm going to talk about a use case around reducing disease here in a second. And we also have systems that can monitor for things like hand washing protocols in hospitals. And so we use Microsoft Connect sort of technology to look and see when nurses and doctors come into a hospital room, do they wash their hands before they talk to a patient? That reduces the number of infections spread in the hospital, systems like this. Let me talk through a typical use case of this technology. So, you know, in the past, all of this stuff used to be siloed, and today what we're doing is hooking it together. So when you look at a lot of the solar panels that are popping up on people's roofs and the wind technology that's coming onto the grid, that's stressing the nation's power grid dramatically because it was never designed to handle that kind of two-way power generation. It was always designed in the beginning to be, you have a power generator and you have a house or a factory, and the electricity goes from the generation to the factory. Now you're getting power coming into the grid at many sources, and oftentimes, if you get too much power in parts of the grid, that can overstress the grid, can even melt some of the wires because some of them are running at such a high temperature and a high capacity today. So balancing out that power grid is a big challenge for a lot of our customers and a lot of what we work on. So we do things that can help at the individual wind turbine level. So the turbine itself can talk to its own battery and can meter how much of the electricity it may be generating that electricity, storing it locally, but not pushing it out to the grid right away if the grid tells the wind farm that it doesn't need that much energy. The wind farm itself, each of the turbines can talk to each other. And if one turbine has a failure in a certain area, for example, sensing the wind direction or the wind speed, it can leverage the sensors and the analytics from the other turbines so that it can align itself to those turbines. The remote monitoring I've talked about a couple of times, where if it starts to have a problem, it can either change its operation to minimize that problem, or it can alert a technician and then guide that technician through the repair. And then the grid itself can be balanced in much more dynamic ways than were possible. And this sort of technology enables the move to renewable power that we're going towards. If you didn't have the analytics to be able to balance the power grid, you couldn't put this sort of the wind farms and the solar in at scale that we need to do. So these are some of the technologies that are required in order to make that work. I talked a bit about the rail side. In addition to the being able to tell the trains what's the optimal speed to run and things like that, we schedule the rail grid. So using analytics, understanding where all the locomotives are, we have a big data analytics application that'll go in and help the railroads plan when the train should go. And by changing the velocity of the rail network by 2 to 3 miles per hour actually has a major impact on the amount of goods that are shipped across the country. The other really interesting part about doing software at GE is being able to tap into the research arm. So GE spends about $3 billion annually on research, and our whole history was based around research. And we're doing some really interesting projects that they're not commercial programs yet, but they're going to turn out in the future to be something I think really game-changing for us. I want to show you one from the hospital side. We look at mashing up different technologies, not just using the latest software technologies from the analytics side, but bringing in a lot of the hardware pieces too. So we have a system that's working now in a prototype in a hospital around reducing the infections in operating rooms. So a lot of times there's a lot of infections that are created through lack of good sterilization procedures on operating room equipment. And in order to do that well, it takes time and it slows down the amount of time or the number of times you can use an operating room in a day. So there's a lot of reasons why hospitals are looking for solutions around automating some of the processes around the surgical sterilization process. So we use robotics here. These robots can go out, it's a number of different robots with multi-agent systems and analytics that go out and they can pick up the tray of instruments from an operating room, the dirty instruments. They can transport them to a cleaning area. They can check the instruments to make sure that they're still working. They can sterilize those instruments and pack them up into kits. They can then go back and prepare the operating room for the next patient, all automatically. So this is the kind of systems that where analytics are coming into play with some of the robotics that GE is developing and some of the traditional equipment that GE manufactures for hospitals. Our approach to building these kinds of systems, this is something fairly new for the company. It's really a couple of years now that we've had software as a core critical component of GE strategy. And our approach was one of organization. We decided to locate a center here in Silicon Valley. We built up a center of about 1,000 people over the last 2 years that's out in San Ramon in the East Bay. And we brought in the best and the brightest people from the Valley that we could find in the areas of high performance computing and big data analytics, just platform creation in general, and web application development. And we've mixed those people with a lot of the brilliant folks that were building the equipment in the industries in GE. A lot of people in GE, software at GE was always a kind of a second-class citizen. It was always about the mechanical engineering that you would do on this equipment. But by bringing the two groups of folks together, we're finding a new culture is emerging, and it's a very interesting place for the software engineers to go work with the actual software that is interfacing with the hardware, and for the hardware people as well. It's just a new way of looking at software. It always used to be these embedded systems that the guys at GE would work on. We're finding it needs new architectures, so we're bringing this consumer-grade architecture to build a new platform, built on open standards, so that developers can use existing tools that we use for building consumer applications, but use them for the industrial internet applications as well. So these are things, before it was extremely archaic. There were languages like Magic and things you have never heard about before that were very proprietary languages or proprietary standards on the data that you got off of these pieces of equipment. Our objective is to build a platform that makes it as easy to write an application for a blowout preventer at the bottom of the ocean as it is to mash up a Google map with some data that you get on the internet. And that approach is opening up a whole lot of new use cases for us, and really bringing a whole different level of talent to try to solve these problems. It's going to change the way that these applications are built, and I think it's going to change the market in general from what today are really niche software companies who have developed an expertise in these areas, and it open up to a wide community of developers to come in and innovate around industrial data the same way that we've innovated around the consumer space. And that's key for us. We know that this isn't something that we should be building ourselves. We're leveraging open source in every case where we can. We're partnering with companies that have key technologies for us, and we're very active in the startup community, investing in startups that have interesting technologies that may be focusing on a different market, but with some of our domain expertise could help us out in solving some of our problems. So it's in the early days for us, and a lot of the examples I talked about are examples that are still, I think, one level of abstraction above the machine. We're looking at these locomotives and figuring out when they need to get fixed. Maybe now we're feeding a throttle setting back, and those are interesting things. But I think there's a whole lot of other use cases out there as you start to think about what would you do with all of this data off of the equipment that we all depend on every day to run our lives, the electric power grid, the aircraft that fly us around, the medical equipment. I think what the exciting part is as we build our ecosystem up and we make this data available and these capabilities available more broadly, we're excited to see what new use cases are going to come out. And I think as we abstract farther away from the machine and look at this data in new and interesting ways, we're going to find a lot of interesting benefits out to society. Thank you very much.
We have time for questions.
What's that?
You got time for questions.
So we have some time for questions if anybody has any questions for us. Yes?
I was kind of curious to hear that GE has embraced open source. When did that come about? I assume that hasn't been always the case.
Yeah, so the question was surprised that GE embraced open source. So when did that come about? This whole move to around the industrial internet and the creation of the GE Software Center was really 2 years ago. And at that point, it was a reset for the company around software. It wasn't always the case, you're right. I think it was, GE is a big company. It has all kinds of software all over the place, but it was all done in silos. And when we came in and we started designing this platform, we really tried to take the same approach that a startup, we talked about ourselves as the best funded startup in the Valley. We took a startup approach to this. And I have to give the chairman, Jeff Immelt, a lot of credit for coming in and trusting the group that he brought in to build this software center, because There were a lot of things that made the company uncomfortable, I think, in the early stages, some of the decisions. But, our belief was embrace the open standards and embrace the open source. That's the only way to drive this. Our area of differentiation in our platform isn't through, duplication of some of that open source code. It's in understanding, how to go access those sensor networks or the control networks, or coming up with the algorithms that rely on deep knowledge of the physics of the asset. So, once the company really got its head around that the differentiation is in different areas, then it really caught on. And now we've got over 80 pieces of open source in our platform today. Other questions? Yes.
So in terms of consumer-facing products for GE, what kind of capabilities are you exposing for that data to the customers? Like, are you making that data available, and how do you expect them to use that?
Yeah, absolutely. So, today there's a strategy going on around our home products. You guys probably know GE Profile appliances, and as mentioned, we have a water heater that connects to the internet as well. A lot of those products, there's strategies in place to look at APIs that allow developers access to that. It's not just on a lot of our products don't touch end consumers. They impact your life, but they're the aircraft engine that we sell. Those as well have open standards and open APIs for access to the data. Now, it's incredibly complicated in terms of data rights. And when you start to look at some of these industries, the home data and all that kind of stuff is a little easier. But then when you look at healthcare data, of course, there's a lot of regulatory requirements around that, and there's a lot of things around the aviation data. And there's different levels of availability of that data. We're looking at interesting ways that we can interact, though, with the development community. We've done a couple of Kaggle competitions. So if you're familiar with Kaggle, the machine learning sort of contest site, we've put aircraft engine data out on Kaggle. We've anonymized that data and put it out there, and put a couple of challenges that we're having around monitoring of these aircraft engines, and we've had really good results with that, and we intend to continue to do that and expand those across other industries as well. So we're moving cautiously because of the regulatory need, but we have a very strong interest to make this data available as broadly as possible. Other questions? Oh, there's one.
Do you find that there's sort of traditional pushback from sort of the old guard in the company for this type of new analysis?
Absolutely. I wouldn't say for the new analysis. I say what I've found is the things that I thought were going to be hard are easy, and the things that I thought were going to be easy are hard. What I mean by that is when I first arrived, our developers had to go to Starbucks to download all the patches for their software because the GE network wouldn't let us out to any open source sites to go get it. The things that I was accustomed to working in larger, I came from SAP before I worked at GE. I was accustomed to trying to beat my coworkers to market on a product. Every time you had a new good idea for a product, someone else would claim it on their roadmap, and then you'd have all these internal battles for it. GE, we don't have any of those kind of problems. I think that the challenge we have at GE are, it's a different culture. It's a mechanical engineering culture. It's very much a hardware culture. And so what we're finding is bringing in some software product management into the mix that can work with the hardware businesses and kind of give them ideas or help them imagine new business models. That seems to be the area where we're the most challenged is just thinking of what are the business ways of using it, because it's not something that the business leaders are accustomed to. Everyone sees the need to do this. All the business leaders see it. The company is 100% behind it. The politics have been a lot less, honestly, than I expected. But I think our challenge is really bringing those two cultures together and creating some synergy between the two. A Silicon Valley software culture with a 140-year-old industrial manufacturing company culture. I think that's the secret sauce. If we can get that right, that's going to be, that's what's going to be the success for us. Any other questions? Great. Well, thank you for your time today. I appreciate it.